Hello, this is Mr. Waterman. This is Pre-Calculus section 9.2 on ellipses. Some of this is review from Algebra 2, but the definition of an ellipse is a set of all points x, y in a plane, the sum of whose distances from two distinct fixed points, the foci, is a constant. So if we were to attach a pencil between these two foci points with a string between them, and the pencil and the string, if we were to trace around with the string tight, we would end up with an ellipse. And so let's go through some terminology. So the point in the middle is the center. For this example, let's say the center is at 0, 0. All right, and we also have the major axis runs horizontally. So the major axis is the longer of the two, so that's pretty easy to remember. And we call this one the minor axis, goes the vertical direction. So from the center, let's go ahead and draw the foci back in here. Foci is plural for more than one focus. And those are defined as being c units away from the center. Okay, so if the center is at the origin, then this would be plus and minus c comma 0. And then we also have, okay, to speed things up, I went ahead and started summarizing some information. So we have foci at plus and minus c comma 0. So they're the distance c from our center, which for this one is at the origin at 0, 0. And then the vertices, the points where this major axis intersects the ellipse, are at plus and minus a comma 0. That's the point. So the distance is a from the center. And lastly, let's look at the co-vertices. So along this minor axis that extends from the center out to the edges of the ellipse vertically on this one, this is called the minor axis, and the co-vertices are going to be at 0 comma plus or minus b. So this distance from the center would be b, and this would be 0 comma negative b down here at this point, this other co-vertex. So standard form of the equation, this one has a major axis that's horizontal, so that's going to be x squared over a squared plus y squared over b squared equals 1. And the foci lay on the major axis with c squared equal to a squared minus b squared. So what's going to happen is they're likely to give you one of these two of these values and make you calculate the third. So let's look at applying this. Alright, so example 1, we're going to find the center, vertices, and foci of the ellipse given by 9x squared plus 4y equals 36. So first thing we have to do is standard form of the equation has the right side equal to 1, so we're going to divide everything by 36. Alright, and that's going to get us closer to standard form. So we'll definitely get a 1 on the right side here, and we're going to end up with something like x squared over 4 plus y squared over 9. Okay, the number underneath x squared, since the major axis is horizontal on this one, we will have oops, I made an error there. So we look at the numbers underneath, and whichever one's bigger is going to be your A value. So this one has a major axis that's vertical because A is the bigger number. So from that we can decide that A squared equals 9, so A equals 3. Alright. And therefore B squared must be the 4. So B equals 2. Right? So we also need to figure out where the foci are, and so we're going to use the relationship from above that C squared equals A squared minus B squared. Alright, we just had those two values, so it's going to be simply 9 minus 4 equals C squared. So C, the distance from the center to the foci, is going to be the square root of 5. So the summary of the answer they were looking for is the center's at 0, 0, the origin. Vertices are at 0, positive 3, 0, negative 3. And the foci are at 0, plus or minus square root of 5. So foci are at 0, C, vertices at 0, plus or minus A. They did not ask us for the co-vertices. Okay, let's look at another example. This time we're going to go backwards. Last time we were given an equation and asked to find some of the major features. This time they're going to give us the features and have us figure out the equation in standard form. So we have an ellipse centered at the origin with a major axis of length 10 and foci at plus or minus 3, 0. I'm going to give you a quick sketch just to show you what this looks like. So it's centered at the origin, and the foci are at plus or minus 3, 0. So 1, 2, 3. So we'll call that one foci, and here's another one over here. So we already know that this has a horizontal major axis. That's because the foci are always located on the major axis. And so if the major axis is length 10, that means that this point over here is at x equals 5. So this is 5, 0. And this is negative 5, 0. Okay, so going back to our equation, which is x squared over a squared plus y squared over b squared is going to equal 1. We know that a squared, well, a is the distance from the center, which is 0, 0, out to the vertices. So a is going to equal 5 on this one. And we also know that c is how far the center is to the foci, so that's going to be 3. All right, from the last example, let's go grab that equation. That's c squared equals a squared minus b squared. We're going to have to calculate the value of b so that we can write an equation. So using this, we're going to substitute in 3. So c squared is going to be 9 equals a squared, which is 25 minus b squared. And if we go ahead and solve this, a little bit of algebra magic, and you get b squared equals 25 minus 9, which last time I looked is about 16. So b is going to equal 4. So we didn't really need b. So now we can go ahead and write our equation. We're going to substitute into x squared over a squared. So we know that a squared is 25 plus y squared over b squared is 16,
equals to 1.
Okay, go ahead and watch video 92B.